Welcome to page 15 of Accel packet number 4. Again, on page 15, we're going to be given a graph of a proportional relationship. We know it's a proportional relationship because, first of all, the graphs we've been given start at 0, 0, and if you look at the line, it's straight. It is rising at a consistent, steady rate. Those two conditions are met, so we know it's a proportional relationship. Let's read our I can statement. It states, given a graph, I can write an equation to represent the proportional relationship. And of course, our equation looks like this. K times X equals Y. We know the K rate, or the constant of proportionality, is found by taking Y over X. Let's see what we're after here after we read a little bit about the graph. Basically, you can see that the x-axis here in this particular story represents the number of cars needed. The y-axis, well, that represents the number of people that you can put in those cars. So as we set up our ratios, you will see that the y is a people number. Please write this down. And the X represents the number of cars. That's a cars number. Well, what are we after? Number one, you have to write a unit rate. Under the line, write the amount per one. Letter B, express the unit rate as an ordered pair. Well, we know we have to represent it with an X and a Y. And we also know that in any unit rate, your X is always 1. And lastly, in letter C, write an equation. And that will look like this. K times X equals Y. We have to figure out what the constant of proportionality, or the K rate, is worth. Let's begin. Whenever you're given a graph, the first thing you should do is to create a small t-table with X, the number of cars, written in the first column, and Y, the number of people, written in the second column. Let's pull a few points off the line. These 3 points have been highlighted. However, we're allowed to select this point, which is 1, 6. One car, X, holds 6 people, Y. Please jot that down in the table. And then let's grab perhaps this point, 318. 3 cars will hold 18 people. Just grab 2 points off the graph. Now, let's write this information as this ratio. Our Y is 6, that goes in the numerator. Our X is 1, that goes in the denominator. Basically, this is your unit rate. 6 people per 1 car. And if we divide 6 divided by 1, we get a K rate of 6. So K equals 6. But you can double check that by placing 18 people divided by 3 cars. That will also produce the K rate when you divide. 18 divided by 3, again, our K rate is 6. So, let's answer our questions. What is the amount per one? Well, that's found right here. 6 people per 1 car. Take a moment and jot that down. Now represent that unit rate as an ordered pair. And of course, it's this one right here. Our unit rate is 1,6. Remember that y is really your K value. And x, well, it's always going to be 1 in the unit rate. And lastly, let's substitute in for the K. 6 times x equals y. And that's the equation you would use for this particular graph. Now complete question 4 on your own. Remember, the key to these particular types of problems when you've been given a graph is to, number 1, set up that table. Make sure you label each column not only with an X and a Y, but what they represent. And number 2, set up the ratio for the K rate, Y over X, and again, make sure you're writing down what the Y represents and what the X represents. Pull a few points off this line, like 1 ticket for every $8. Grab another one. 2 tickets for every $16. And put those ordered pairs in the table and work with them. Make sure you're coming up with the unit rate, the ordered pair, and the equation. Use the notes from above if you get lost. Pause your video right now, take down these notes, and when you're ready, complete the problem. Please pause your video now. You should have gotten the following: $8 per 1 ticket, the ordered pair 1,8, and lastly, $8 times every ticket X equals Y, the cost. This concludes page 15.